Hello, everyone. Welcome back to another episode of Coding with Culp. As always, today is a great day to learn how to code. While you're at it, why don't you go ahead and like the video, subscribe to the channel, and feel free to comment down below about anything that you find interesting about the video. However, today we're not really going to be learning to code. We're going to be taking a look at one of my very favorite platforms for learning to code or teaching people to code on, and that is the Raspberry Pi. I've owned a Raspberry Pi of some sort ever since they first came out, and I absolutely love the platform. But today specifically, we're going to be taking a look at the Raspberry Pi 500. We're going to unbox it. We're going to take a look at it. We're going to go over all of its specs, and we're going to check out also the new Raspberry Pi monitor that got released along with the Raspberry Pi 500. And then finally, and the main point of this video is I want to put the Raspberry Pi 500 through a stress test just to see how it handles heat under load, and then overclock it and stress it out again and see how it handles that heat. One of the biggest issues I've seen or I've experienced with the Raspberry Pi 5 is heat. That little machine can really crank out some heat, especially when it's overclocked and under load. My Pi 5 8GB that I use on a regular basis, I've got a massive heat sink and a fan on it to cool it down, and it struggles. When it's fully under load, it can get up to about 60 degrees or so Celsius, just 20 degrees shy of the thermal throttle temperature. So I kind of have my doubts the Raspberry Pi 500 here is going to be able to stay under that thermal throttle temperature of about 80 degrees Celsius under load, and especially when it's overclocked. But we'll find out. When the Raspberry Pi 5 was originally announced, my immediate response was, hey, that's great. That's awesome. Where's the Raspberry Pi 500 though? Because I really liked the Pi 400. I loved how it had kind of this compact and functional design. It was an all-in-one design, which to me was kind of reminiscent or reminded me of classic computers like the Commodore 64, the Apple II, Atari 800, etc. And it was those machines that I originally learned to code on way back in the 1980s, and I spent a huge portion of my teenage years with the Commodore 64 learning to code. So one of the great things about those old machines like Commodore 64 was they were all in one. You turned them on, they booted directly to a development environment. Now that development environment was basic, but still, there was nothing to install, nothing to configure, nothing to update. It was just this blinking cursor of possibilities waiting for you to enter code. And in my real life job, in my everyday job, that's what I do. I teach kids to code. And sometimes I think that one of the big barriers to kids today easily learning to code is that there are very few experiences like that I had in the 1980s of just turn the machine on. It's ready. You don't have to install anything. You don't have to configure a development environment. You don't have to do any of that. Just turn it on. And the Raspberry Pi 400 and now the Raspberry Pi 500 comes really, really close to that. So without further ado, let's go ahead and let's unbox this thing. All right, let's go ahead and let's get this thing open. So the Raspberry Pi 500 is actually available in two different configurations or models or whatever you want to call it. You get this one, which includes only the Raspberry Pi 500, nothing else. It does come with a 32 gigabyte pre-formatted, ready to go SD card. However, you can also get the Raspberry Pi desktop kit, which, by the way, this was $90. Can't remember where I got it. I'll look it up and put a little notation in the video. But anyways, you can get the $120 desktop kit, and that desktop kit adds the Raspberry Pi mouse, a 27-watt USB-C official Raspberry Pi power supply. It includes a 2mm micro HDMI to HDMI cable, and then a little book, the Raspberry Pi Beginner's Guide 5th edition. So let's go ahead, let's continue opening this thing up. Oops, I got it upside down. Ah. All right, so there we go. Let's take it out. All right, so the Raspberry Pi 400 was that red and white color scheme. This one's all white. It's kind of hefty. I like the way it feels. Feels actually pretty good. Actually feels a little bit better, or well made, more well made. Is that a real word sentence? Anyways, then the Raspberry Pi 400, and then the keyboard. I have to admit, I don't consider myself to be a keyboard snob. However, the only keyboards I use are mechanical keyboards, and I absolutely despise these little chiclet style keyboards, which you're always stuck with when you've got a laptop or something like that. But this one actually feels pretty good. It's a little clicky. The keys have a little bit of travel on them, so they actually feel okay. I hate those chiclet keyboards that have very little travel on them. So I could work on this. It's not too bad. Let's look at the back, see what we got here. Right here we got USB. We got 2 USB 3 and 1 USB 2 port. We have a micro SD card, which comes already with I think it's 32 gigabyte micro SD card, pre-installed with everything you need. Right here, this USB C slot is for power. You have 2 micro HDMI ports, which, once again, I'm not a fan of micro HDMI, but I absolutely 100% understand why they've gone with micro HDMI, because it's got a far smaller footprint. So, whatever. You've also got a gigabit Ethernet port here. This little thing here is a Kensington lock. So if you work in an environment where you might need that, you can actually lock this thing down so it can't be walked away with. But overall, it's pretty nice. The actual machine itself is 2.4, let me think, 2.4 gigahertz quad core, 64-bit ARM Cortex A76. It comes with 8 gigabytes of LPDDR4, which I was super happy when they announced that the Pi 500 was going to come with 8 gigabytes of RAM. I was really afraid that they were going to bring it out with 2 gigabytes or 4 gigabytes. I honestly believe that it really needs 8 gigabytes to really feel like a good desktop experience. And the Raspberry Pi 5 is one of the first Raspberry Pis. The Raspberry Pi 4 to a smaller extent, but to me it's one of the first Raspberry Pis that actually feels like a good desktop, not a desktop replacement, but it does have a good desktop experience. And if you really needed to, you could probably use it as a desktop replacement. One of the big things when I was teaching kids to code with the Raspberry Pi 2 and the Raspberry Pi 3 is, as soon as they boot it up, it starts into a graphical user environment, and they want to use it just like they do a home computer, the PC they have at home, or the Chromebook or whatever it is that they use. And so they immediately want to open up a web browser and then open up 27 tabs and YouTube and online games, and it just didn't work on the Raspberry Pi 2 or 3. Whereas the Raspberry Pi 5, you still can't open up 27 tabs and everything else, but it gets you a little bit closer. It's got a Video Core 7 GPU. The micro HDMI ports here are capable of 4K 60. It's got dual band 802.11 AC Wi-Fi, Bluetooth 5. I already said gigabit Ethernet port, and this right here. Let me see if I can remove that. See if I can get it out. Maybe. This is the Raspberry Pi GPIO connector. Hang on. All right, here we go. There we go. Popped out. So there, right there's your Raspberry Pi GPIO header. So overall, it feels nice. I mean, for $90, that's not too bad. Let's go ahead and let's take a look at the Raspberry Pi monitor real quick. So here is the newly released Raspberry Pi monitor. It was released on the same day that the Raspberry Pi 500 was released on. I got this from one of my favorite places, Adafruit, but I love that place. I have ordered so much stuff from them. And I got the Raspberry Pi 500. I just looked it up from Canakit. So it is a 15.6 inch display, 1080p. There's the back of the box. So let's take a look. All right. Let's pull this thing out. See what else we have in here. Well, let's take a look at the monitor first. Let me put this to the side. All right. So there we go. It for $100, I will admit it does feel kind of plastic and maybe a little bit cheap, but for $100 that's not bad at all. Over here we've got power button, volume, brightness controls. Let's see here. Little kickstand. What have we got right here? Looks like we've got power, so USB-C goes in there. We've got HDMI right there, and that looks to be either a microphone or a headset plug-in. Not bad. So then it would sit kind of like that. We're going to hook this all up to the Raspberry Pi 500 here in just a few minutes. All right. Okay, let's see what else is in the box. So over here, let's see here. We've got that looks like a USB-C cable. Yep, USB-C cable. That looks to be about it inside of the box. Little instruction manual, information booklet. All right, let's hook it all up. Let's get it going. Okay. Here we are. We have the Raspberry Pi monitor, and I've got it hooked up to the Raspberry Pi 500. Now, there are two different ways to power the Raspberry Pi monitor. Way number one is that you can power it directly from the Raspberry Pi. All you have to do is run a USB-C cable to the back to the power port from your Raspberry Pi. The other way is that you can power it from a standard USB power supply, which is what I'm doing. When you have it powered with the USB power supply, you can go to 100% brightness, whereas if you power it from the Raspberry Pi, you are limited to 60% brightness. Now, I would really like to say that this is the first boot, and you get to see the first boot of the Raspberry Pi 500, but unfortunately, it's not. I had shot all that, and then when I downloaded it to the computer, my mic wasn't plugged in, and there were a few other technical issues. So I'm having to reshoot this at the end, but I wanted you to see the monitor running, the Raspberry Pi 500. So let's go ahead and let's turn it on. I'm really impressed with the monitor. I think it's got, great visuals. I'm not I don't know what you call a AV aficionado or anything, but for $100 at 1080p, I think it's great. So yeah, there it is. I've got the Raspberry Pi overclocked right now because I'm going back and reshooting this at the very end. So let's see here. Yeah, everything seems to be working just fine. Tell you what, let's just go ahead and see if we can overclock this thing just a little bit here. Sneak preview. it crashed at this 3.1 gigahertz later on in the video. But let's see. All right, sudo reboot. Let's see if it'll boot. If not, we'll go on to the other overclocking tests and thermal tests. So far so good. Oh, hey, we got a boot screen. We got a boot screen. Splash screen, and now we got nothing. Oh no, look at that, look at that. Oh wow. So yeah, we've got we're at the desktop. So far so good. 3.1 gigahertz. So this is kind of overshadowing or foreshadowing, I guess, what's coming up next as we go and overclock and attempt to, test the thermals on this thing. But I got it to 3.1 gigahertz. Nice. Let's go ahead. Heck, once again, a little foreshadowing. Let's run the stress test real quick. See if it crashes on the stress test. Let's see here, 38.9, and bam, right up to 3.1 gigahertz. Nice. Once again, foreshadowing. I'm really impressed, or I was really impressed with the Pi 500. Anyways, I will put these results at the end of the video. I might mention them in the final thoughts or something. So anyways, the monitor is great. It's awesome. And let's go on to the test now. All right, here we are. I have installed VNC, or got the VNC server running. I'm going to show you how to do that real quick so you can connect to your Raspberry Pi graphically over the network. So in order to do that, you have to enable the VNC server. There's two different ways, or a couple different ways you can do that. The way I prefer is you open up a terminal window. You're going to type in sudo raspi config, press enter. You're going to come down here pressing the arrow buttons to interface options. You're going to press enter. You're going to come over here to the third option, which is VNC. You're going to press enter. And you're going to say, would you like the VNC server to be enabled? You're going to say yes. I'm going to go ahead and hit escape to get out of here because I have already enabled it. And let me get out of here. There we go. The other way to do it is you come up here to the upper left where you have the Raspberry Pi icon. You're going to click on it. You're going to scroll right over here to preferences. Then you're going to come over here to Raspberry Pi configuration. It gives you the exact same options, just graphically. So you can come over here to interfaces, and you're going to come down here to VNC, second option there, and turn it on or off. All right, let's hit cancel. So in order to stress test this thing, there are a couple of packages that we have to install, and what I'm going to do is I'm going to link to a web page that'll show you what you need to do. You essentially need to download a package, the source package, compile that source, and then run this command right here. What this is going to do is it's going to stress out the CPU. Every core it's got, max it out, and it's going to print the temperature for us. So let's go ahead and let's start running this thing. So you can see 4 CPUs, 4 cores. It's a quad core processor. This is our frequency. So we're running at 1.5 gigahertz right now. We got a temperature of 36.7 degrees Celsius. And then it does it again. We're now at 2.4 gigahertz. Now we're at maximum speed, 2.4 gigahertz. You can see our temperature's rising, 48.3 C. And we're going to do this for 900 seconds. So what I'm probably going to do is I'm probably going to stop recording and come back in about 10 minutes. But we're right up there at 48.8, getting close to 15. Remember, 80 degrees is that magical number. 80 degrees Celsius is the number we don't want to get close to. When you start getting up there to 80 degrees Celsius, the Raspberry Pi 5 is going to start thermal throttling. What that means, it's going to start turning down its speed in an effort to cool off. We're at 50 degrees. It's going to continue to rise. So let me stop recording, and I'll come back in about 10-15 minutes and see where we are at. So I am really impressed. If you take a look, this is where the run ended. Successful run completed in 900 seconds. And you can see we never got above 57, 58 degrees. Yeah, I don't see a temperature above 58 degrees Celsius at all. That's incredibly impressive. And we ran at a all out 2.4 gigahertz the whole time. So let's hit Control C, exit out of that, and now let's start overclocking this thing. All right. We had some pretty good thermals, actually pretty impressive at the stock 2.4 gigahertz. However, what we're going to do now is we're going to start overclocking the Pi 500. And we're going to do it in a few steps at a time and test the thermals each time to see how they do. So to overclock it, what you're going to do is you're going to open up a terminal window, and you're going to edit a text file. And you can use whatever text editor you want, whether it's Nano or Vim or Emacs or whatever. It doesn't matter. And so you got to type in sudo sudo super user do /boot /firmware /config.txt. What am I doing? Sudo vim, there we go, or sudo nano, etc. /boot /firmware /config.txt, and there we go. Okay. Now you're going to scroll down, and the options we need to edit are not in here. So when I scroll down, what we're looking for is ARM_freak, GPU_freak, and overvoltage delta. And if you scroll down here, you're going to see that they're not here. So we're going to add them. So what I'm going to do, I'm going to come over here, and I'm going to add those parameters. I'm going to say ARM_freak equals, and the default is 2400. We're going to go up to 2800 or 2800. That's 2.8 gigahertz on the ARM CPU. And we are going to do GPU_freak equals, and we're going to stay at 900. We're going to go with 900, and we're going to leave overvoltage alone for right now. So this should be 2.8 gigahertz and 900 megahertz on the GPU clock. So let's give that a try. So in Vim, escape, WQ for write with quit. Now I have to reboot. Now if it doesn't reboot, okay, don't panic. If you can't reboot after you've tried overclocking, just take the SD card out, put it into a Windows machine, a Mac machine, another working Raspberry Pi, it doesn't matter. And on the root directory, you're going to see that config.txt file. Just go in there with a standard text editor, not a word processor like Word or something. Go in with a standard text editor and simply edit it back down, okay, to 2800. So here we go. Let's reboot. And let's see if we are able to reboot. All right, so over here to my right, I actually have the Raspberry Pi 500 and the monitor going, and so I'll see if it reboots. And let me get VNC ready to go. Oh, it's booting. It's booting. Come on. And there we go. It's booted. So let me go ahead and go into VNC. Might not be fully up yet. Let's try it again. There we go. When you're overclocking, you're really hoping you won the chip lottery. Some are far more overclockable than others. My regular Raspberry Pi 5 that I use on a constant basis, I can't get it to go above 2.9 gigahertz, but I've heard of people going much higher than that. So now let's go back to our stress test and let's try it again. Oh, I gotta go grab the line, so let me do that. There we go. All right, paste it in here. Okay, there we go. I had some difficulty getting it to copy and paste. That's weird, but let's go ahead and let's start. So once again, it's a 15-minute test. You can see we're at 1.5 gigahertz right now. Temperature of 40 degrees Celsius. It should ramp up to 2.8 here in a second. There we go. 2.8 gigahertz. So let's go ahead. Let's watch it for, just a bit, and then we'll shut down and come back. We're already up to 54. 55. Once again, we're fine until we start getting up there close to 80 degrees C. All right, I'm gonna shut down and we'll come back in about 15 minutes. Okay, so we're at the end of that 15-minute test at 2.8 gigahertz, and you can see we stayed somewhere around 67 degrees. I don't see anything getting above 68, but now we're only about 13 degrees away from that thermal throttle temperature, at 67 being our highest. So what we're going to do is we're going to go ahead and we're going to up that overclock a little bit. And so same thing, we are going to do sudo vim boot firmware config.txt. And we're going to come down here and let's go ahead and let's overclock to 3 gigahertz now. And I'm going to leave the GPU freak at 900 still, but let's go ahead and let's try to go to 3 gigahertz. So escape WQ, and now I got to reboot. So we'll find out if we can go to 3 gigahertz. What? Oh, there we go. All right, so over there to my right, I can see that the Pi has shut down, and of course my VNC connection got disconnected. And we're booting. We are booting, ladies and gentlemen. I see activity on the screen. It just got to the Raspberry Pi boot screen, and we are now at the Raspberry Pi desktop screen. So hopefully the VNC server reconnects. Well, let's see. If not, I'll just do a manual reconnection. Nope, we got it. We're at 3 gigahertz, ladies and gentlemen. So let's do another 15-minute test at 3 gigahertz. So we're going to enter that exact same command, and let's go. Let's do it. And right there, it starts out right at 3 gigahertz. Temperature of 46.6 degrees Celsius. So far, I've actually been pretty impressed with the thermals on the Raspberry Pi 500. I really didn't expect it to perform that well. The heatsink on it is just a big piece of aluminum. I may, in this video, I don't know yet, take it apart and show you what it is. We're already up to 62 degrees. Let's give it another minute or two. 63. And 64.8, getting close to 65. So we're going to shoot past that 67 that we were at 2.8 gigahertz. In fact, we should beat it by quite a bit. I should feel the Raspberry Pi, see how it feels. I can feel that heat coming off of the Raspberry Pi keyboard. I mean, I can definitely feel the heat. It's not uncomfortable or anything like that, nothing ridiculous like that, but I can definitely feel the heat on the keyboard. Oh, and feeling underneath it, it is definitely warm. Yeah, it's absolutely warm. I can feel that heat right there in the center back, and I can feel it right on the keyboard itself. The whole thing feels a bit warm. No, like I said, nothing uncomfortable. All right, we're at 67 degrees. I'll be back in about 10-15 minutes when this test completes, and we'll see how it did. Okay, so we are very close to the end of the test at 3 gigahertz, and we are incredibly close to thermal throttle temperature. You'll see we haven't thermal throttled here. We're staying at 3 gigahertz, but we're at about 74.7. I think that's the highest temperature that I've seen, 74.7. So, oh, what's going on here? Oh no, I think my Raspberry Pi 5 has crashed. It did. It did. All right. Wow. All right, let's reboot this thing. So we got up to about 75 degrees, but it was not stable at that overclocking settings. It crashed there at 74.7 degrees, and it just crashed. I mean, like right when I started re-recording. So let's reboot it, and let's make a couple of changes to that config.txt file, and see if we can get it to be a little bit more stable. Now, I will say that the Raspberry Pi 500 does seem to be a little bit more overclockable maybe than the Raspberry Pi 5. I can't get my Raspberry Pi 5 above 2.9 gigahertz. I mean, I can't do it. And so let's try something real quick. Let's mess with over voltage settings. So here we go. And I don't normally mess a lot with over voltage, but let's go ahead. And we're going to do over voltage delta equals 5,000. And let's save it. And now let's reboot. Whoa, rebot? Really? Is that how I'm going to spell that? All right. There we go. So let's reboot it and see if we can get it to be stable at that 3 gigahertz. And if I can get it to be stable at that 3 gigahertz, I think I'm happy with that overclock. And like I said, at 75 degrees, we're getting really close to that thermal throttle of 80 degrees, somewhere around in there. I think it's 80 degrees that thermal throttle's at. So I don't think we could go really much higher than that. So let's see what we got going on. All right. Uh-oh. Hang on. Oh, hold on here. Over here on the right, it's doing weird stuff. Ooh, I can feel the heat on that thing when I pick it up. It is warm. I mean, really warm along the bottom. All right, I'm having to reboot it manually. I had to unplug it and plug it back in because it just wasn't stable enough to even execute that shutdown command properly. All right, it has rebooted. It's at the desktop screen, so it should fire up the VNC server, and we should connect here momentarily. Maybe. Oh, there we go. All right, so we're back, And let's see if overvolting that is going to give it a little bit more stability. Like I said, it wasn't even stable enough for it to completely execute that shutdown command. So let's come back over here once again. Oh, let's do our stress test and see how it does. All right, so we're 1.5 gigahertz, temperature 48.8. Should go, yep, there we are at 3 gigahertz, and it shot way up to 62 already. And let's see what we get. 62, 60, almost 66. So once again, I'm going to let it run till it crashes or it's done, and I'll be back when either one of those two things happens. Okay, I got some great news. Bumping that overclock, or bumping the overvoltage up a little bit, we got stable again, or it appears to be stable again. So we just finished the test, and it looks like the highest temperature we got was 77.4. You were pushing almost 78 degrees, and that's incredibly close to that thermal throttle temperature. I don't know that we could go much higher, but you know what? We're gonna try. We're gonna see if we can. Right now, I'm incredibly impressed. I have no issues. The Raspberry Pi 500 at $90, being able to overclock it this far, keeping it cool, well under that thermal throttle temperature, just absolutely amazing. So, I highly recommend it if you're into Raspberry Pis. But let's go ahead and let's see if we can go just a tiny bit higher. If it doesn't work, I'm not going to, try anything further. So this could be the end of the video. But let's go ahead and, whoops, that's not what I meant to do. Let's go ahead and edit that file again and run the test again. So there we go. All right, let's go down to here and let's do this. Let's bump that GPU freak to 1000, and let's go ahead and bump the ARM freak to 3100, and let's see how we do. All right, I wonder if I do have to reboot. What am I thinking? All right, let's go ahead and reboot it. All right. So I'm watching over here to the right, and so far nothing. Oh, we just got the Raspberry Pi splash screen, but it is locked up on. Yes, it is locked up. It is not going to boot. So, I think that's the end. That's as far as we're going to be able to take it. So let me leave you with a few final thoughts. I'm really impressed with the Raspberry Pi 500, and especially its thermal capabilities and overclocking capabilities. Like I said, my Raspberry Pi 5, it's 8 gigabyte model, I've never been able to get it above 2.9 gigahertz, no matter how hard I tried, no matter what settings I, played with. And this Raspberry Pi 500, I got it at 3 gigahertz. It's really no problem at all. I stopped at 3.1 gigahertz. I can probably, I think I can probably get it stable at 3.1 gigahertz by playing with a few more settings. And in fact, I did get it to eventually boot at 3.1 and kind of stay stable. But I really think I could probably get it to 3.1 by playing around a little bit. But 3 gigahertz is just fine. I was really impressed with its thermals. Like I said at the very beginning of the video, I didn't have a lot of confidence in the Raspberry Pi 500 because that heatsink is just a piece of thin aluminum. And I was really impressed. Got all the way up to 3 gigahertz, running it all out, all 4 cores running at 3 gigahertz. at 100%, and it stayed underneath the thermal throttle temperature. Just barely under it, but it stayed under it. I'm also really impressed with its fit finish. I think it's well worth $90. Just depends upon what you want it for. I suspect that the Raspberry Pi 500 will probably find a market just like the Raspberry Pi 400 and most of the Raspberry Pi line with retro computing and the retro gaming community, and then of course in education. If I could, I would buy 25 of these, maybe 30 for my students. They're absolutely great for learning to code on. The Raspberry Pi monitor at $100 is also a really nice deal. It's a great monitor, great fit and finish. Like I said, it does feel a little light and a little plastic, but it's a $100 monitor. And by the way, I wasn't paid. Nobody sent these to me. I bought these things with my own money. I would really appreciate it if you could like and subscribe to the channel. Most YouTube channels, most successful YouTube channels have a, good cohesive theme that holds them together, kind of ties them together. And this channel does not. It's mostly retro computing, coding, technology, that sort of stuff. I've got a video about an Altair 8800 full-size clone coming up, if you know what that is, an Apple One. I've got a couple of Pi game stuff coming up. And, so if you're into that kind of stuff, yeah, go ahead and like and subscribe. I got some stuff coming up about the Commodore 64, the Mega 65, all that good stuff. So until next time, thanks a lot for watching. I really appreciate it, and bye-bye. Stop the presses, everyone. I got it to 3.1 gigahertz successfully. Completed a run of stress, a 15-minute run. We got up to a maximum temperature of I think around 76.3, so still under that 80-degree thermal throttle. Came really close to 80 degrees, but we're still under at 3.1 gigahertz. So I was able to do it. I got it up to 3.1, and you know what? I think I can probably eke out just a tiny bit more. But so far so good. It's actually running pretty well. I want to try one thing real quick. Test one more last thing. One of my favorite little demos, GLX Gears, which I think is that part of Mesa Utils. Let's try this. Whoops. Okay, yeah, that was it. So let's see how many frames per second we can get out of Mesa, or out of GLX Gears. All right, let's see here. Hey, there we go. And it's running pretty smooth. Oh, 60.79 frames per second. And let's run it with the frame rate uncapped. I can never remember how to do that, so I had to look it up. Give me just a second here. I think it's this right here. VBlank mode equals 0. GLX Gears. Let's give that a try. All right, let's go back. It did not copy. All right, let's try it again. Or I'll just type it manually. Okay, whatever. All right, let's see if that works. Let's see what we get. Ooh, 4,670.575 frames per second out of GLX gears. That's pretty good. I mean, for, something like a Raspberry Pi. Nice. And it appears to be running nice and stable and smooth at 3.1 gigahertz.